good afternoon, and good evening to all of you from IEA Paris headquarters. Today we are fortunate of having a very distinguished panel to discuss a crucial topic on which the International Energy Agency released a new major study just last week: the role of critical minerals in clean energy transition. It's my pleasure now to invite the International Energy Agency Executive Director, Dr. Fatih Birol, to open this event. Dr. Birol, the floor is yours. Thank you.
Thank you, Mr. Bilazi, and greetings from International Energy Agency headquarters, Excellencies, dear colleagues. Welcome to this meeting where we are going to discuss the critical issue of critical minerals in the clean energy transitions. Now, some people may ask the question, why the IEA, an energy organization, works on minerals issue? Because when you look at the IEA work, we work on oil, gas, renewables, electric cars, nuclear power, efficiency, all of these things. Why minerals? The answer is very simple. Critical minerals are essential to make tomorrow's clean energy system work. Because when we talk about the clean energy future and addressing climate change, when we think of the tomorrow's energy system, we see networks, electricity networks, digital. We see electric cars, we see solar panels, we see wind turbines, we see electrolyzers, hydrogen, and others. And unlike the most of the existing energy system we have in the world, they do not need oil or gas or coal to run, but they need critical minerals to be built. Without the critical minerals built and without their being the ingredient of the future energy system, we may not be successful to reach our climate goals. So therefore, as IEA, we thought, on one hand, we are very happy to lead the global clean energy transition, pushing for new advanced technologies, but we said we must also look at the critical minerals and rare earths as we think this is a part of our energy security mission. So, our report, which we have published last week, and when we have such a new and challenging report, I go to my colleague, Mr. Tim Gould, to coordinate this such a work, bring the energy, economics, investments together, and him, but especially the report's lead author, my colleague Tae-Yoon Kim, made an outstanding report, and the report is everywhere. We thought in this meeting, we may discuss a bit the perspectives from a region which is, I think, vulnerable to the future challenges coming from critical minerals, and we are delighted to have the government leaders, government officials from Japanese government, from Korea, and from Australia, in addition to all other colleagues. Now, if we are serious to reach our climate goals, and we have heard the leaders of Japan, Korea, and Australia recently at the summit of United States President Mr. Biden, they all committed to a clean energy future, then we believe these countries also need to pay attention to the critical minerals issue. For two reasons, at least for two reasons. One, the economics of it. Because Mr. Tae-Yoon Kim's report shows that the demand for critical minerals will skyrocket. I'll give you one example. Lithium. Lithium is very important for electric cars, for the solar panels, for others. And the demand for lithium in a world which follows a climate constrained world, demand for lithium will increase 75 times. 75 times. It is similar in cobalt, nickel, many other critical mineral sources, and this may well put a pressure on the clean energy transitions and making it more costly if we do not take necessary measures by the governments, by the industry. So one reason is the security, the economics, and the second reason is security, because as our report shows, some of the minerals and the supply chain to refine them are concentrated on a very few number of countries. And this may well cause some challenges. It may be a physical disruption. It can be a geopolitical issue that if a very few number of countries have a control of some of the critical minerals availability and the refining system, this may well mean that the clean energy transition may slow down or hamper. So it is a second reason, economics of it and the security of it, why we have made this study, and we came up as with some recommendations to governments. I would like to finish by saying that the International Energy Agency, we have been an agency looking after the oil crisis, oil shocks, years and years. It was the main reason why IEA was founded in 1974 by Henry Kissinger and his colleagues. Then we have recently addressed the issue of electricity security, and including the cyber security. And now we are hoping that the ministers of the International Energy Agency, who are going to meet first quarter next year, will ask the IEA Secretariat, in addition to oil and electricity, to pay attention to monitor the critical minerals security. Monitoring it, having stress tests, and increase the transparency, we hope our ministers will ask us to do in our ministerial meeting first quarter next year. So it is the reason at the IEA I built a task force to prepare the ministerial meeting, and today we are fortunate that my colleague, Mrs. Nicole Thomas, who is a distinguished member of this task force, is with us, who is going to tell us a few things about our ministerial meeting and moderate this session. With this, I thank all three governments actively participating in this discussion, and those governments who are following this webinar. Now I am going to turn to Mrs. Thomas for her remarks.
Thank you so much, Dr. Birol, and thank you everybody, distinguished guests and excellencies, for joining us today. As the Executive Director has mentioned, this new report is really important for the IEA, and we're really pleased to have you join us. So the report, it does two things. It analyses and quantifies what we see as a potential hazard for energy transitions, but it also identifies what needs to be done. So in the way through the 6 recommendations that the IEA has developed for a comprehensive approach to mineral security. So this, I think, is very much the spirit of today's IEA. We're not observers from the sidelines, but we're actively and constructively involved in finding solutions, working together with members of the IEA family. So that is why this issue, I guess, is on the radar of the Ministerial Task Force. It's preparing the ground for the next IEA Ministerial meeting, which we're expecting to hold in the first quarter of 2022. And as ever, an evolving energy system, it calls for constant vigilance on new risks to energy security. We, as the IEA, have to be aware that if energy transitions are not secure, then they will not be rapid either. So this report reflects the IEA's determination to stay ahead of the curve, sort of on all of the aspects of energy security. This is why we've placed such importance on electricity security, including integration of the rising share of renewables. We're also following closely how the digitalization and automation of energy systems increases the scope for cyber attacks. So the availability of critical minerals is another emerging issue that we think requires very careful consideration by policymakers. And this is why we're delighted to have such a distinguished set of speakers at our event today to discuss some of the issues that are impacting on and engaging our key countries that we're speaking to here. So with those introductory comments, I'd like to start off and kick off our high-level panel. So I'd first like to introduce our first speaker, His Excellency Mr. Washio Aiichiro, the State Minister for Foreign Affairs from Japan. Minister Washio, over to you.
Dr. Birol, Executive Director of the IEA, distinguished speakers, ladies and gentlemen, and those who are viewing this program online. My name is Aiichiro Washio, State Minister for Foreign Affairs of Japan. Thank you very much for inviting me to this momentous event, and it is my great honor to speak here today. I have been informed that this report is a groundbreaking effort that shows what energy security in the 21st century is all about. I have been eager to participate in today's webinar. 2020 was a symbolic year in which many countries, including Japan, expressed their commitments to decarbonization. Countries that already made these commitments account for more than 70% of the world's GDP and emissions, which I believe is a very encouraging figure. The year 2021 hosts many important meetings, beginning with the IEA COP26 Net Zero Summit in March, followed by the G7, G20, and COP26. One key takeaway, and what I found particularly important in this report, was how it redefined the notions of the energy security. For realization of decarbonized society, energy security is shifting from being fuel intensive to being material intensive. I was struck by the idea that the central point of energy security is shifting from ensuring fuel as an object of consumption to securing and recycling materials for building facilities produce renewable energy. The report also warns that the current scale of investment will not meet the demand for minerals needed to achieve the goals of the Paris Agreement. However, we cannot leave future generations with a delayed energy transition and a decarbonized society with soaring energy prices. I agree that there is an urgent need to expand investment in projects that can meet the necessary level of an accelerated energy transition and promote innovation. In order to secure a stable future supply of mineral resources, many issues must be resolved, which include realization of fair markets, protection of human rights, assurance of transparent labor standards, and consideration of the environment. The new challenges will be to expand the application of high standard rules based on the universal values which the international community has embraced after years of effort in the field of mineral resources. The international community, the public and private sectors, and consumers need to actively discuss these issues. Japan will continue to make positive contribution to this important agenda. Finally, I'd like to conclude my remarks by hoping that this report and webinar will contribute to deepening the international community's understanding of these new dimensions to energy security. Thank you very much for your attention.
Thank you so much, Minister Washio. I think that's a very important point that you make, and we really hope that this report does help progress that understanding and international collaboration on this issue. So I'd now like to hand over to our second speaker and welcome His Excellency Mr. Ejima Kiyoshi, the State Minister of Economy, Trade and Industry in Japan. Minister Kiyoshi, the floor is yours.
Well, thank you, Ms. Chair. I'm Ejima Kiyoshi, State Minister of Economy, Trade and Industry. I would like to show my gratitude for this opportunity to speak today. Since last year, in the face of the unprecedented crisis and difficulties of COVID-19, the IEA Secretariat, under the leadership of Dr. Birol, has been working vigorously together to launch reports and hold various conferences. I would like to once again salute the efforts of the IEA. Also, we highly appreciate that for the first time, the IEA has published the special report on critical minerals. The IEA has positioned critical minerals on the perspective of energy security, while Japan and other countries around the world are accelerating their efforts to decarbonize. I would also like to express my sincere appreciation to the members of the IEA Special Report in Critical Minerals team. Today, while taking into account the IEA report, I would like to explain Japan's policies to secure a stable supply of resources for critical minerals whose demand will increase during the transition to clean energy. Japan depends on imports from overseas for almost all of its mineral resources. Therefore, the most important mission of Japan's mineral resource policy is to ensure a stable supply of these resources based on international trends. At the recent Leaders Summit on Climate, Japan aims to reduce its greenhouse gas emissions by 46% in the fiscal year 2030 from its fiscal year 2013 levels, setting an ambitious target which is aligned with the long-term goal of net zero by 2050. Furthermore, it is to be stressed that Japan will continue strenuous efforts in its challenge to meet the lofty goal of cutting its emissions by 50%. As pointed out by the IEA, critical minerals are indispensable for the production of batteries, motors, semiconductors, etc., which will be key to the transition to carbon neutrality, and the demand for them is expected to increase in the future. In addition, there is always the risk of supply disruptions for critical minerals, such as rare earth, most of which depend on specific countries, and international competition for access to them is expected to become more intense. In response, Japan has been strategically addressing this issue using a combination of policy measures that I will now discuss in the following. One, diversification of supply. Two, strengthening the global supply chain from upstream to downstream. Three, cooperation with governments and international organizations. Four, improvement of the national stockpiling system, in preparation for supply disruptions. Also, we will pursue new possibilities for the development of mineral resources. The numbers of profitable mining projects have decreased around the world, and the risks and costs of developing new mines are rising. There is great potential for the development of new technologies in the future, especially in the area for the recycling of materials contained in used products, as well as resource saving and alternative technologies such as rare earth-free magnets that do not use minerals with a high supply risk. These efforts must be focused on the perspective of sustainable development that avoids environmental destruction. As mentioned, there are many challenges in securing a stable supply of mineral resources. However, we must solve them one by promoting responsible policies. In addition, these efforts for critical minerals are in harmony with the 6 recommendations of the IEA Special Report. 1, ensure adequate investment in diversified sources of new supply. 2, promote technology innovation at all points along the value chain. 3, scale up recycling. 4, enhance supply chain resilience and market transparency. 5, mainstream higher environmental, social, and governance standards. And 6, strengthen international collaboration between producers and consumers. As stated in the recommendations of the IEA report, in promoting these efforts, it's very important to utilize the knowledge of the IEA. METI staff also contributed in the process of developing of this special report. We will continue to work closely with the IEA under the leadership of Dr. Birol to steadily advance our efforts toward achieving carbon neutrality. Last but not least, once again, I would like to show my deepest gratitude toward the report team for their contributions, and we wish for the IEA's further contributions to the stable supply of critical minerals around the world. That brings me to the end of my presentation. Thank you for your attention.
Thank you, Minister Ejima, for your excellent intervention. We're really happy to hear the importance of minerals security in Japan and the efforts that you're making to strategically encourage both energy and mineral security through the global energy transition. It's great to hear the consistency with our 6 key recommendations in this report, and we'll really look forward to working with you as we take these issues forward. Thank you again. I'd next like to welcome His Excellency Mr. Ju Young-jun, Deputy Minister for Energy and Resources from Korea. Minister Young-jun, over to you.
Thank you, Ms. Nicole Thomas, Dr. Birol, and Excellencies. I'd like to begin by extending my gratitude to the IEA Secretariat for hosting today's event. The importance of critical minerals is greatly highlighted, as we can see from the growing demand everywhere. In this sense, I find the IEA's latest report on critical minerals very meaningful. I hope today's meeting will pave the way for more specific action plans. I believe that critical minerals will continue to play a key role in achieving carbon neutralities and developing new industries and low carbon industrial structures. Global cooperation between IEA members is crucial to ensure a stable supply and demand of critical minerals, and ultimately achieve our global net zero target. In this regard, I'd like to share a few ideas. First, it is important that we establish a global system to prevent the weaponization of critical minerals and create a stable and resilient supply chain. For instance, I believe we can establish an international stockpile system that is open to both producing and consuming countries. If we member countries agree on establishing such a new stockpile system, we need to carry out the joint research as soon as possible. Second, we need to join force to develop innovative technologies for the entire value chain of critical minerals. Innovative technologies to develop, produce, and recycle critical minerals can help reduce material intensities and encourage the material substitutions. This will in return help lower the prices of clean energy technologies as well as address supply shortages. In this regard, innovative technology is a must for a sustainable supply chain. I look forward to finding new technologies for critical minerals following our previous success in developing clean energy technologies. Third, I need to take an active interest in establishing ESG standards. Such a standard will help prevent environmental pollutions and labor safety issues in the course of producing minerals. By applying ESG standards during the entire stage of mineral development, we can promote the sustainability across the entire industries. Also, as we all know, many countries with critical mineral resources on their own land are often reluctant to operate producing and refining facilities due to the environmental concerns. Therefore, if we could establish more agreeable ESG standard, I believe we will ultimately be able to diversify such a supply source of critical minerals. As you may know, the Korean government is also formulating a national policy to create a stable and resilient supply chain for critical minerals. Under this policy, Korea plans to increase its stockpile volume, provide extensive support for the development of recycling technologies, and strengthen cooperation with major producers in other countries. The Korea government will spare no effort to contribute to IEA's action plan by sharing its experience with member countries. Once again, I'd like to thank you for this opportunity, and I look forward to continuous discussion between IEA members. Thank you.
Thank you so much, Deputy Minister Young-Jun. I think you've made some really important points in there, so including on the role of stockpiling, the need for technology development, and the social and environmental concerns. All of these have been really important and really pertinent for the IEA, and we hope that the insights in the report are helpful for you as you continue your consideration. And we also, as you mentioned, hope that this report can pave the way towards developing some specific action plans, and look forward to working with you and your colleagues on that. I'd now like to introduce our final speaker for the high-level panel, His Excellency Dr. Alexander Robson, Ambassador and Permanent Representative of Australia to the OECD and IEA. Over to you, Dr. Robson.
Thank you, Chair, and thanks, Dr. Birol. It's a great pleasure today to join you and the IEA team, as well as the esteemed ministers from Japan and Korea, to talk about this special report on critical minerals and the clean energy transition. I'd like to first really recognise the work of the IEA and congratulate Dr. Birol and the entire team over there, particularly, as has been mentioned, the contribution of the lead author, Mr. Tae-Yoon Kim. And it's really a testament to the fact that the IEA continues to create and provide high-quality, evidence-based analysis and advice that guides members as well as the global community. As has been pointed out, this report really comes at a crucial time for IEA members as well as non-members as we seek to redefine the concept of global energy security, and as the world drives forward on the transition to a clean energy economy and net zero pathways. It also comes after our Treasurer, Josh Frydenberg, yesterday handed down the 2021-22 budget. And in that budget, we announced our global resources strategy, It builds on previous work in this area and demonstrates Australia's commitment to assisting industry in identifying and accessing new markets and supply chain opportunities, both domestically and internationally. The discussion today will hopefully be the first of many on this really vital topic, bringing together like-minded member states, industry stakeholders and research partners to further explore the role of critical minerals. And for Australia, as our Prime Minister has recently said at the Leaders Summit, it's not a question of if or even when on net zero for Australia. It's really a question of how, and critical minerals are a key part of the how on this issue. So I'd like to talk about three things. Firstly, production, and then supply chains, and then sustainable mining. On production, as demonstrated in the IEA report, Australia will continue to be a key contributor to global emissions reductions via the global supply of lithium, and therefore to the creation of strengthened battery storage, the electrification of our generation and industrial sectors, and the transformation of transport sectors right across the world. Australia is the world's largest producer of lithium, producing just under half of the world's supply last year. However, we will also grow our contributions to other critical mineral supply chains. We already produce 9 of the 10 minerals used in lithium-ion batteries, and we have the world-class resources for the 10th, graphite. More generally, of course, we are one of the world's leading producers of many major mineral commodities, including copper, nickel, zinc, bauxite, coal, lead, gold, ilmenite, iron ore, rutile, and zircon. The 5-year outlook of Australia's March 2021 Resources and Energy Quarterly explores the forecast growth of resources and the importance of the sector to the global economic recovery from COVID-19. It also highlights Australia's expected growth in critical minerals production. With a number of new projects to come online, Australia will continue to reliably produce and export a number of minerals that are so vital for the clean energy transition right around the world. The second point I'd like to address is on supply chains. We recognise the need to strengthen and diversify global supply chains of critical minerals. Diversifying these supply chains is necessary to ensure resilience and stability, as others have noted, and to buffer against disruptions. Currently, the supply chains of many of these minerals are highly concentrated, and that increases supply risk. And this is, as Dr. Birol pointed out, a key issue that's highlighted in the IEA's report. There's growing recognition among like-minded countries about the need for more diverse global supply chains, particularly as increased future demand for some critical minerals will create bottlenecks and further strain these already fragile supply chains. So, drawing on our expertise in minerals processing, Australian industry is developing processing capabilities outside of these concentrated supply chains. We are a proven and dependable resource exporter, and we're open for business. As one of the most technically advanced, innovative, and efficient resource producers in the world, we're ready to share our world-leading expertise in resource extraction and processing, high-tech engineering, and clean energy research. We're actively seeking opportunities for new partnerships, particularly in the Indo-Pacific region. These partnerships, we think, will strengthen diversification of supply chains and enhance the resilience and the economic recovery of Indo-Pacific economies. The final topic I'd like to touch on is sustainable mining. Australia's support for sustainable mining initiatives through the development of programs in a number of key partner nations has seen over $28 million invested in support of extractive governance and transparency. Supporting sustainable mining, for example, in Mongolia and across South America enables these countries to expand their own rare earth and critical minerals industries, leading to greater supply and enhancing the diversity of supply chains. And that's a key lesson we've all taken from the effects of the COVID-19 pandemic. So it's these types of programs that will also prove invaluable as we seek to identify the new technologies going forward that will enable the clean energy transition. And these technologies will likely rely heavily on existing and new critical mineral supplies. So to conclude, the growing role of critical minerals, both to global energy security and in contributing to the global clean energy transition, really continues to be a key area of importance and investment for Australia. That's why we so warmly welcome the IEA's work and encourage the IEA and member states to continue to explore how these recommendations in the report can be turned into positive actions and inform our evolving understanding of global energy security. So we look forward very much to taking the findings of this report together with the IEA's ongoing work on its 6 pillars to the 2022 Ministerial meeting. This engagement and oversight will aid in ensuring ongoing collaboration on work that will be vital for the successful energy transition and energy security right across the global community. Thanks very much.
Thank you so much, Ambassador Robson. As both an Australian national and a member of the IEA Secretariat, I'm really pleased to hear about Australia's focus on this issue, and which I think it will be really critical to help diversify global supply chains, as you mentioned. It's also great to hear about your work on partnerships within the region, because I think that the best way that we as a global community will be able to support energy and mineral security, as well as the sustainability of the development of those minerals, will be to work together. And I was really glad to hear you mention that working towards these issues towards the Ministerial. I think it will be really important to keep all of these issues in mind as we reflect on and develop what energy security means in the current world. So thank you all of our excellencies for the excellent interventions today. I think we've got some really good perspectives and some really good input for the IEA to consider as we continue working on this issue and taking it forward. So I'd now like to, with that, to hand over to Mr. Tim Gould, who's the head of our Energy Supply and Investment Outlooks Division at the IEA, to moderate the remainder of the event. So including a presentation of the key findings from the report in a bit more detail and a discussion with our expert panel on the mineral market opportunities and risks. So thank you again to our distinguished guests, and we look forward to keeping you all engaged through the rest of the panel and event. Thanks again.
Thank you very much, Nicole, and sincere thanks to all of our speakers at this high-level session for raising, in fact, all the key themes that we will develop during the remainder of today's event and our excellent panel. We've heard a lot already about the new report from the IEA, and so it seems appropriate now to fill in some of the detail on the key findings, and there's no better person to turn to for this task than to the IEA's Tae-Yoon Kim, who was the report's lead author. So for the next segment of our event today, I would like to pass the floor across to my close colleague, Mr. Tae-Yoon Kim, to make that presentation. Thank you, Tae.
Thank you, Tim. It's a pleasure to be here to talk through some of the key findings of the critical mineral report. So I'll be brief. To start with, over the last year, despite the pandemic, we have seen some growing momentum for clean energy transitions. Many countries and companies announced pledges to reduce emissions to net zero by mid-centuries. These are yet pledges, but as they turn into actions, it implies a massive acceleration in clean energy deployment, solar panels, wind turbines, and electric vehicles. But a clean energy system is fundamentally different from the one fueled by hydrocarbons, in a way that they need a lot of minerals and metals to build. Lithium, nickel, cobalt, manganese, graphite are vital for batteries performance. And rare earth elements are crucial for performance of wind turbines and electric vehicle motors. Solar panels are not very mineral intensive, but the sheer scale of capacity addition means the plenty of additional demand for copper, silicon, and silver. And grid networks, transmission and distribution lines, which is the backbone of our power system, requires huge amount of copper and aluminum to run. So that means we are shifting from the pure centric energy system to a mineral intensive energy systems. For example, a typical electric car requires 6 times more mineral resources than a conventional cars. Likewise, offshore wind requires 13 times more mineral resources than a similar sized gas-fired plant. There's no shortage of mineral resources, but there's also no guarantee that supplies will be available at affordable prices at the right moment when you need them. So this requires some evolving approach to energy securities. Minerals and supply chains are increasingly becoming an important part of the energy security debate. These challenges are manageable, but requires early attention from policymakers to avoid damaging outcomes. One key question we had to answer at the start was, how much do we need by 2040 and 2050? And the short answer is, in a climate-driven scenario consistent with the Paris Agreement, we may see a quadrupling of overall mineral requirement by 2040 compared with today. An even faster energy transition to hit the net zero emissions globally by 2050 may require 6 times more mineral resources than today. But we are seeing 4 to 6 times here in the graph, but some of the minerals, we made the relative scale of growth is much, much larger. For lithium, we may expect some 40 times more mineral demand in the climate-driven scenario. And as Executive Director mentioned, in a fast net zero scenario, we may see some 75 times growth for lithium. And likewise, graphite, cobalt, nickel may see some 20, 25 times demand growth compared with today. One implications of this rapid demand growth is about the cost of clean energy technologies. We know we have seen the rapid cost decline of major clean energy technologies over the past decade because of the technology learnings and economies of scale. But the outcome of that, result of that is now the raw materials account for a larger share of total cost. So that means the higher prices, higher and volatile mineral prices can have a major impact on the cost of clean energy technologies and on the cost of clean energy transitions. And also there are some major roles for companies that produce and process the minerals in the clean energy transitions. For example, revenue from coal production is today 10 times larger than the revenue from energy transition minerals. But this picture is set to change over time in a climate-driven scenario as coal use goes into structural declines and energy transition minerals gain a tailwind from the rising demand and upward pressure on prices. And by 2040, the combined revenue from energy transition minerals overtake that of coal production well before 2040. And this can have a major implication for companies' business decisions. And also there could be some social consequences to manage. On the supply side, one of the key concern is the higher level of geographical concentration of productions. For lithium, rare earths, and cobalt, the top 3 producing nations control well over 3/4 of global output. But it's not just about mining. When it comes to processing and refining operations, the level of concentration is much more visible with China's strong presence across the board, as the country has invested heavily in the mineral supply chain to support the growth of the clean energy technology manufacturing industry. The issue about this high level of geographical concentration is that when there is some physical event or trade restrictions or other development in major producing countries happens, and it can have a major impact on global supply and global prices with impact on consumers. Another question we asked ourselves on the supply side is whether the supplies will be in a position to keep pace with rapid demand growth. But the result is we look at the expected production from existing mines and also the production from under construction project. And as it stands, today's investment and supply plans are geared to a world of more gradual and insufficient action on climate change, and not sufficient to keep pace with the rapid demand growth in a climate-driven scenario. So there's some looming mismatch between the strengthened climate ambitions and the supply of minerals. And these challenges are compounded by the additional concerns such as the long lead time to develop the new project and also declining resource quality that posing upward pressure on emissions and production costs and waste volumes. So the ability of supply to keep pace with demand growth cannot be taken for granted. And another question we heard regularly when we are conducting this analysis is how clean is the clean energy technologies when you take into account the emissions from mineral development. So we look at the choices today between buying a gasoline-fueled car and buying on electric vehicles, and looking at their life cycle emissions. So gasoline-fueled car, there are some emissions from the manufacturing phase, but majority of them occurs by combusting fuels. For electric vehicles, they have some slightly higher emissions from manufacturing processes because of the batteries and also the emissions from mineral development. But even though when we consider the higher emissions from mineral development, the difference between the conventional car is not that huge. So effectively, in terms of life cycle emissions, the questions boils down to the question of electricity to power the vehicles. But with the global average electricity mix in the climate-driven scenario, the result is overall the life cycle emissions of electric vehicle are just half of those of conventional cars, with the additional potential for additional reduction by 25%. So the emissions from mineral development is important, but don't negate the climate advantages of clean energy technologies. But still, it is very crucial to tackle these emissions because many of the energy transition minerals have a higher emission intensity than other commodities. But we saw there are some large variation in terms of emission performance among different players. So that means there's some measures to tackle these emissions by fuel switching or using low carbon electricity or improving energy efficiency, etc. So overall, to conclude, we came up with some 6 key pillars of actions to ensure the mineral securities. The first one is to ensure the adequate investment in diversified sources of supply. With this, the most important thing is for policymakers to give some strong signals to market players saying that energy transitions are going to happen. This will be vital to reduce investment risks and attract more capital to the new project. But supply side measures alone are not sufficient to tackle all these challenges. So technology innovation can play an important role here to allow for some more efficient use of mineral resources and enable some substitution and unlock some new supply sources from lower grade ores or waste streams. And the recycling is very much important to reduce the burden on primary supply requirement. For example, we are expecting some surge in the amount of spent EV batteries from around 2030s. If not addressed, these burgeoning volumes of spent batteries will pose some pressure to manage waste. But if well addressed, these can be a valuable sources of resources, especially for regions with the greater clean energy technology deployment. So there are some strong security benefit that this recycling can bring. The fourth item is enhancing the supply chain resilience and market transparency through the various tools such as emergency response exercise and periodic market stress test, and the voluntary stockpiling in some cases. The fifth element is mainstreaming the higher environmental and social standard. And this can bring major security benefit and help effort to diversify the sources of supply. And finally, no single country can address these challenges on their own. So there's some strong case for international collaboration between the producers and consumers through the regular policy dialogue and coordinations. And there are many opportunities for policymakers by acting together. And on our side, the IEA stands ready to help government tackling these challenges and avoid some damaging outcomes for our planet. So I will stop here, and thanks for your attention.
Well, thank you very much, Tae-yoon. And now I would like to invite our distinguished panel to join us on the screen and to thank once again our speakers in the earlier high-level session. And I would like to introduce our panel. I see already Dr. Fiona Wild, who's Vice President for Sustainability and Climate Change at BHP. I also see on the screen Mr. Andrew Hutchinson, who's head of the Critical Minerals Facilitation Office at the Department of Industry, Science, Energy and Resources in Australia. I'm delighted to see Dr. Andrew de Wit, who is a professor in the School of Economic Policy Studies at Rikkyo University. And I believe we also have, yes, Dr. Tae-hyun Kim, who is a senior research fellow at the Korea Energy Economics Institute. And it's great that we have all of you with us today. And Tae-hyun Kim will also remain with us for this discussion. And I'd like to start by going to Dr. Wild, if I may, because we've heard a lot about investment issues, and as you may be aware, this question of ensuring adequate investment is kind of the first item in our sort of 6 pillars of action. I wanted to get your perspective on how challenging it is to engage with investors and the finance community. So is there a change in investor sentiment towards these energy transition minerals? And also, in your view, sort of how serious are investors and financiers about the kind of the ESG aspects of all of this when they, when you take your investment decisions? So perhaps you could give us some perspectives on these issues. Many thanks.
Thanks very much, and thank you for the invitation to join you today. It's a real pleasure to participate. I would certainly say that compared with even 3 or 5 years ago, the discussions that we have on environmental, social and governance or ESG related issues are now core to all investor engagements that we have at BHP. But within that broader bucket of ESG issues, climate change is definitely the key issue, particularly around the targets that we set and how we deliver against those operational decarbonisation goals. But also increasingly, there's a focus on value chain decarbonisation. This engagement with investors presents a real opportunity, I think, to build understanding. All of us are learning a bit more about the risks and opportunities that we're seeing. We can share lessons learned, and we, importantly, as has been mentioned by previous speakers, look for ways to collaborate across sectors, including between the financial and the non-financial sectors, to really try and limit the financial impacts of climate change, but bring some of these opportunities to fruition as well. One of the things I would say is I think there is still a lack of recognition of the critical role of mining and metals to support a low carbon transition. So as we've heard, we won't see rapid electrification without copper. We won't see a build out of decarbonisation infrastructure without steel. We won't see a scale up electric vehicle batteries without nickel. This really plays into a broader question that investors are wrestling with, which is how do you allocate emissions between sectors in order to set benchmarks against which to test company performance? So as we know, the pathway to achieving net zero will look very different for every commodity. So the steel sector will not decarbonise at the same rate as the power sector. And I really think the IEA can play a pivotal role in helping investors understand plausible decarbonisation pathways and aligning around realistic milestones along the way. In terms of levels of commitment, I think the investment community is certainly committed to making more informed decisions that more adequately consider climate-related risks and opportunities. And I think the Task Force on Climate-Related Financial Disclosures, or TCFD, of which I'm a member, has been pivotal to really encouraging the disclosure of decision-useful climate-related information for investors. but there is still a long way to go to improve understanding, to coalesce around the most relevant tools and metrics, and really ensure that investment catalyzes the decarbonisation that's required to achieve the goals of the Paris Agreement.
Yeah, thanks very much. That's fascinating, and it echoes some of the things that we see, you know, in other sectors in which we're looking at closely. I'd like to turn now to Professor De Wit, because you know, speaking from Japan, a country that sort of lacks some of these resource endowments. I mean, we heard from Minister Washio and Minister Ejima the importance of technology innovation for more efficient use of minerals or substitution. We heard how that plays a very important role for Japan. So could you give us your assessment of Japan's efforts to date on that sort of technology front?
Yes, thank you. And thank you for inviting me to this event, this important event. Yes, Japan's public policy on critical minerals actually has a long history. It's dates back to the early 1980s, when they've been using government to encourage stockpile of materials even before most of the other. I think the more advanced public policy or industrial policy on critical materials is only found in China, according to some studies. Anyway, so Japan is quite advanced, has been quite advanced for several decades now, and particularly as we entered the 2000s with, you know, ICT, the globalization of ICT and other kinds of items, because Japan is so large a producer of critical mineral intensive products and has no domestic resource endowments aside from what might be developed under its external economic zone. It expanded its list of, gradually expanded its list of critical minerals, and it went from stockpiling to focusing on emphasizing overseas projects, advanced recycling, substitution, and more aggressive stockpiling. The question is, how fruitful have those initiatives been? Okay, well, I can take an optimistic spin on it and say, sure, you know, advanced recycling has been a major priority. Japan now seeks to expand a collection of recyclable materials domestically and from overseas. There's a new effort to drill down on tungsten, cobalt, and 3 select rare earths in particular, not only, but in particular. At the same time, there are multiple issues confronting recycling. If you look at the data, there are multiple issues confronting recycling, including difficulties collecting dispersed devices. I mean, it just becomes incredibly inefficient to try to bring all these things together. It's also difficult to separate critical minerals in amalgams. So we're waiting for breakthrough technologies where maybe you melt them all down and do some special process that liberates the various rare earths and other materials within, you know, smartphones and semiconductors and so forth. Because as you know, they're extremely complex amalgams. And then there are the increasingly recognized limits to harvesting the so-called urban mine. So that's, you know, on the positive side, you have these initiatives, and on the other hand, you do see the limits in Japan. Similarly with substitution, there's, you know, talk of using nanotechnology to promote substitution, but you know, and there are various centers of excellence pursuing these initiatives, but they're constrained by higher costs, degraded performance, and substitution within critical minerals, meaning, you know, swapping nickel for cobalt, for example, which is sort of like a whack-a-mole kind of thing. It's not, doesn't get you out of the problem per se. And so there's much to learn from Japan, you know, on using good public policy to pursue, you know, to the extent possible, to pursue, robust supply chains and resource as much as possible, some resource independence. But on the other hand, if you look for actual quantification of how much these things have provided to Japan's overall reliance on imported critical minerals, one's struck by a lack of really good, transparent data. So personally, I'm looking forward to your initiative in promoting that, promoting the diffusion of best practice, but transparency on data rather than simply, we're doing this and we hope that this will achieve X or whatever, but show us the numbers. Thank you. I'll stop there.
No, thank you very much, Dr. David. And indeed, as we were putting together this analysis, we drew a lot of inspiration from the public policy initiatives that have been implemented in Japan, or particularly over the last decade. And you've raised some issues that I'd like to take up now with Dr. Kim from Korea. I mean, Korea is a leading manufacturer of EVs and storage batteries. So I'd like to ask your views on how companies are acting on battery reuse and recycling, and maybe you recognize some of the issues and the challenges that were just mentioned by Dr. David. So what is your view on the key challenges, and how do government policies in Korea intend to help address some of these issues? Dr. Kim. I think we need to unmute. There we are.
Okay. Thank you for inviting me to this event. As electric vehicle grows more common, reuse and recycling of batteries are also becoming more active in Korea. For example, Hyundai Motor is starting to engage in reuse, and LG Energy Solution and SK Innovation are beginning to actively engage in recycling business. However, currently, amount of spent batteries is low, so there is no economy of scale. There is no profit. Spent batteries from electric vehicle were collected solely by local government. They pay the subsidies for purchase of electric vehicles and are accumulated in the government storage warehouse. When the lack of space becomes visible, the government lifted the regulations on spent batteries. As a result, the regulatory sandbox was introduced that allows automakers and the battery companies to collect the spent batteries, conduct various pilot programs, and develop new business models. Thank you.
Thank you, Dr. Kim. That's very helpful in understanding Korea's perspective on these issues. I'd now like to switch to Mr. Andrew Hutchinson from Australia, and maybe we heard a lot. We heard from Tae-Yoon earlier about the rise in expected demand. We heard from Ambassador Robson about Australia's resource potential across a wide range of critical minerals. So from your perspective, what do you see as the most significant challenges or risks to bringing online an increased supply of these critical minerals and metals? And what sort of measures are you implementing in the Critical Mineral Facilitation Office to address some of that? Mr. Hutchinson, over to you.
Thank you, Tim. Thank you, everybody, for hosting me tonight. Apologies for my inelegant dress and background. I'm hiding in my garage with my kids rampaging around above me. So apologies if there's any noise coming through on that as well. Look, it's an excellent question. And, I think we should all acknowledge the incredible opportunities and benefits here of the move to electrification. And Australia, as our Ambassador Robson so eloquently pointed out before, we're really keen to be at the forefront of this and helping to meet world demand of these critical minerals. But it is not an endeavour that is risk-free. And it is something where we face a number of challenges, and I'd like to sort of step those through as I see them. So in the Australian context, at the very least, I really categorize that there are three main risks facing these projects, or three factors that, that are acting to create risk around these projects. The first is that, by and large, taking, for example, rare earths as a case, there is an enormous amount of technical challenge associated with these projects. In Australia, these deposits are scattered around the country. The mineralogy of each of the deposits is quite different. We are an extraordinarily efficient mining nation, but these projects are not solely about mining. The further up the value chain you go, it rapidly goes from mining to industrial chemistry to advanced manufacturing. So in order to achieve the most cost-efficient way of processing these minerals, you actually often need a bespoke flow sheet or solution at the mine site, involving a number of steps of flotation, mechanical crushing, acidification, and then if you move into rare earth oxides, you're actually basically running a whole laboratory process with several hundred stages of chemical separation to get the rare earth elements out, because they are so similar to each other, and the ores that they occur in are so different to each other. So it's a very challenging proposition. There is no one-size-fits-all model for these deposits, and so the expertise pool in particularly outside of China is very limited and almost has to be reinvented each time. The second category of challenges is really around the kind of project delivery and financial risk. In Australia particularly, a lot of the companies that are looking to exploit these deposits are mid-tier to junior mining companies, and so they often have a relatively limited market capitalization of sort of somewhere between 200 million to a few billion. But the projects themselves can be enormously capital intensive. So a typical, again, a rare earth cracking and leaching facility, maybe with an oxide separation plant, you might be looking at $1 billion, $1.5 billion, depending on how far you want to go. If you're a small company that's got a market cap of $200 million, that's a very big ask you're putting to a financing institution or to the equity markets. And all this to do something that, as I've already said, is technically risky. The third is really around this existential market risk that a number of the speakers have spoken about tonight, where we have very concentrated supply chains and particular pinch points in those supply chains where particular firms or particular countries really effectively control the market, or effectively or actually control the market. This can lead to an enormous amount of price volatility and concerns in investors' minds about the worries associated with strategic behavior. So all of these different kinds of risks combine to create what I think is the main thing that we need to focus on, which is really a catch-22, to excuse my parochialism. You have a small company asking for a lot of finance, and there's a lot of risk attached to that ask. And so the financiers obviously, rationally, say, if we are to consider loaning you this money, we want to see this project de-risked. The best way to de-risk it is to have a binding offtake agreement with a customer who will provide you with some certainty of pull-through, and ideally some price protection in the form of, for example, a floor price. That, of course, is a very big ask to put on a customer. And they're going to be really nervous about backing a project like that might not come online for several years unless they're, of course, sure that the financing is going to come through and the thing can be delivered. And so you can get trapped in this cycle, this catch-22. Now, that sounds dreadfully negative. Let's be honest, none of these are unsolvable problems. None of this is rocket science. This is a matter of risk allocation and a matter of establishing a new model of business that, once it's up and running, the private sector will use its innovation to mainstream and to de-risk. There is a huge role for governments here. There is, whether that be in the form of an export finance agency, whether that be in the form of a government stepping in to invest directly, as we've seen Japan do so successfully through their financing agency with Linus, and more recently with the US Department of Defense and Linus, or whether we're talking about something more oblique like an underwriting agreement or a government-to-government agreement, or a stockpile. There are lots of different ways to do this. Just to come back to my 3 tiers of risk, Australia is trying to attack all of this at the same time on many fronts. For technical risk, we have some of the best science agencies in the world that focus heavily on mining engineering technology solutions, rare earths, nuclear science. So our Nuclear Science Technology Organization and our CSIRO are very active in this space and work closely with industry. On the project and financing risk, that's a personal crusade of mine. We work very closely with 3 different government financing agencies, including our Export Finance Agency, to understand these projects and find the most cost-effective and risk-effective way to back them. We also have government grant programs such as our manufacturing initiative, and critical minerals is one of our priority areas for that. And finally, on the concentrated and opaque market situation, we're working bilaterally and multilaterally with key partners, focusing particularly on like-minded countries to explore what can be done at a government-to-government level to encourage industry to invest directly. So, you know, it's fighting a battle on many fronts. We're making some great progress, and we think we can crack this nut and play a real role in helping the world meet its objectives as it moves towards net zero. Thank you.
Yeah, thank you very much, Hutchinson. That was very lucidly going through all of the different aspects of this, and indeed there are many parts of that we'd recognize from looking at the way that we need to scale up investment in a host of emerging technologies during the energy transition process. But you've sort of overlaid that with, you know, some of the more, as you put it, existential market risk issues that arise in some of these value chains. So that was extremely valuable. I'd like to now, perhaps we can take the next question a bit closer to home. I'm looking along the desk here to Tae-Yoon Kim, because during your presentation, you highlighted the issue about improving ESG performance and said that could help address security of supply. And I mean, that's not an intuitive link, you know, and so I'd like you to explain why that might be the case. And so what you think, you know, needs to be done about addressing some of these environmental and social issues. So, Tae-Yoon, please.
Thanks, Tim. Yeah, actually, people tend to think improving the environmental and social performance and enhancing the security of supply is a separate thing. But I think there are some strong linkages between the two, because the investors and consumers are increasingly calling for the volumes that is sustainably and responsibly produced. But if the environmental and social performance don't rise, and the consumers will compete for the small pool of supply, and that will create another additional market strains. So we estimate some 10 to 15% of global lithium, cobalt, copper production comes from the regions with the lower governance scores and higher emission intensity. So the reducing that share and improving the working together to improve the environmental performance can bring some substantial security benefit, I think. So in terms of that, I think there are some 3 key elements to improve that environmental performance across the board. The first thing is the integrating the environmental and social consideration at the early stage of project planning, project design. And the second thing is we think the supply chain due diligence can play an important role in this field. And there are some well-known frameworks such as the OECD due diligence guidance. But the key task is now to bring this from the voluntary basis to a well-designed regulatory frameworks. So that is a second, I think, important task. And the third thing is the companies tend to disengage from some regions with some lower performance. But I think this engagement is not an answer. So engagement is an answer. So there's some scope for companies and government and from majors to transfer some knowledges, the best practices for responsible and sustainable development to regions to improve the performance there. And that can bring some substantial security benefit, I think.
Thank you very much, Tae-Yoon. I'd like to stay on a sort of a similar theme and come back to Dr. Wild on these kind of ESG issues, because one of the things that we came across as we did this analysis is that there's quite a wide variation in the sort of environmental footprint of different producers. And indeed, you know, if we look at all of these minerals and metals that are vital for clean energy technologies, you know, some of them have relatively high emissions intensities. So what, from your perspective, are the most important things that companies can do to bring down related emissions? And could you also comment, please, on the role of regulation in that respect?
Sure, thanks very much. Well, certainly at BHP, one of the core responses we've put in place is to set and deliver emissions reduction targets. So we've been setting operational emissions reduction targets since the 1990s. And we now have a whole range of different targets, from a short-term target to keep our operational emissions at 2017 levels in 2022, through to a medium-term target to reduce those operational emissions by 30% by 2030, and a long-term target to get to net zero by 2050. So you can see there's that pathway to net zero that we've put in place at BHP. And you're right, each commodity has its own emissions profile, but broadly speaking, about 40% of our operational emissions come from electricity consumption, about 40% comes from diesel combustion, and the remainder comes from what we call fugitive emissions. So achieving net zero at BHP really requires us to do three things. It's about switching to renewable electricity, it's about removing diesel from material movement, and it's addressing those hard to abate emissions like fugitives. Generally speaking, the first cab off the rank is electricity. It's relatively straightforward to switch to renewables, whether that's building behind the meter or through PPAs. Next up is diesel, which is more challenging because we need to look at alternative fleet or alternative methods of mass material movement, like trolley assist or in-pit crush and convey. And that really requires a collaborative approach across industry. So we can't work in isolation on that. And then for fugitives, the focus is really more on research and development. And that's where we may need to look at the role of offsetting emissions to get to that net zero position until a solution becomes available. More broadly, though, I think understanding and driving decarbonisation through business processes is key. So this needs to become business as usual, and we need to link it to remuneration policies. On policy, I think it's really great to see the momentum that's building in the lead up to COP26, and it's certainly been reinforced by the outcomes of the US Climate Summit just a few weeks ago. And there is no doubt that long-term and effective policy frameworks are key to supporting an acceleration of effort from companies. But along with ambitious national targets, we also need market mechanisms that can enable emissions reductions at lowest cost. So I think from our perspective, we look forward to seeing increased ambition from governments and the catalytic effect that that will actually have on the pace of global action.
Yeah, thanks very much, Dr. Wild. And that, I mean, everyone's been very disciplined with their answers. So we have around 10 minutes left. And in that time, I'd like to turn to other panelists with some thoughts on this notion of international collaboration. Where can it usefully focus its attention? You know, what could be achieved? And I'd like to start with Dr. Kim, because if I understand well, in addition to your work on minerals, you've also worked a lot on Korea's policies to ensure oil and gas security. So could you start by giving us some thoughts on what can we learn from traditional energy security approaches? So from oil or gas or even electricity, you know, how relevant is that experience or those learnings for the discussion about mineral security? I think we're going to have to go for unmuting again. There we are.
Sorry.
No problem.
Critical mineral also need the security policy measure similar to oil. In Korea, not only oil, but also energy transition mineral depends on imports. The government and the private sector combined hold about 190 days worth of oil stock. And the government is stockpiling for critical mineral, but it's not as big as for oil. In addition, Korean government is supporting companies abroad to invest in resource development of both oil and the minerals. When it comes to diversifying the source of import, Korea currently has a support policy in place for oil, whereas similar policy measures are still needed for critical mineral. However, it is important to note that critical minerals have a slightly different market structure than oil. For example, petroleum products are consumed directly by a large number of consumers for several purposes. And the transport sector, for example, gasoline and diesel are consumed directly by consumers in all countries for driving vehicles. However, unlike petroleum, critical mineral in EV battery materials, consumers are mostly producers or companies related to electric vehicle battery. So a country with a larger EV battery industry may be more committed to mineral security. Therefore, I think that the resource security policy measure may differ accordingly. Thank you.
Yeah, thank you very much, Dr. Kim. And indeed, we were discussing many of these similar questions. As you're all aware, the IEA has got some long-standing experience on all sorts of aspects of energy security. So we've been talking to different colleagues across the agency about the relevance of that experience to this debate. I'd like to turn now to Dr. DeWitt, because as you explained a little bit earlier, I mean, Japan has long been engaged in these issues of mineral security. And I'd like to just, in a sense, ask for your assessment of what went well and how you think the relevance of Japan's experience there for sort of a new discussion about international collaboration on these issues.
Yes, thank you. Okay, well, what went well, comparatively speaking, they've managed to create these centers of excellence on substitution, recycling. As of last year, the stockpiling targets have been significantly increased. They went from a generalized target of 60 days, with some variation in there, but generally 60 days for critical minerals, to a tripling of that, but depending on the mineral and depending on other aspects. They've increased the capacity of the the JOGMEC, the Japan Oil, Gas and Metals National Corporation to underwrite projects overseas, as well as they're debating on raising that even more by the end of the year. So, and they have also reduced the rare earth reliance. As of 2009, I think it was 85% of rare earths were imported from a particular country. I don't want to say the name, but and reduced that in 2018 to I think it was 58%. And aim to get it down to 50% by 2025. And so we've seen some successes. There's also this commitment through the recent Quad agreement with the US, Australia, India, and Japan to collaborate on critical minerals. And so you've got this kind of action going and great potential. But if I may, I'd like to return to a point that was made by our MOFA speaker at the start of the event, and calling for an engaged public debate on these kinds of things. Because without that kind of engagement, probably you're not going to get acceptance of perhaps higher prices, through higher ESG standards and so forth. And that's where I might, it's sobering to read your report, particularly in light of the fact that right now Japan is undergoing a revision, deliberating on revisions of its triennial energy strategy, within which the last one barely addresses critical minerals. And so you would expect that in the lead up to this summer is likely the point at which the revisions will go through, that there would be a considerable debate going on. But that's not apparently the case, from what I can gather. And one would hope that in the wake of this event and the participation of our distinguished speakers in the first section, that Japan doubles down on doing that and starts to link out. I mean, Japan has a problem when it, whether it's with energy per se or critical minerals in particular. There's a scarcity of think tanks and comprehensive public policy schools and so forth that try to enumerate the implications of these kinds of developments for broader things like urban planning and issues like that. And one would hope that Japan could be a leading example. As we're going through these deliberations on the energy strategy, there's still time, it's only May, right? That we could see some deep engagement engagement on critical minerals, essential for the deep decarbonization that we all say we want. And so I would hope that that eventuates. And if you can, please apply pressure. Anyway, thank you very much.
Yeah, thank you very much, Dr. David. I'll come back to some of those points in a minute, but I'd first like to go to Mr. Hutchinson, because we heard just now about some existing national initiatives, some existing international initiatives, and I'd like to ask your perspective, because you spoke earlier about what you were doing from the facilitation office about some of the risks that you identified. So what do you look for in international collaboration initiatives that could help to address some of those issues?
It's an excellent question, Tim. I'll probably give you more of my view of the world on that this is absolutely not a whole of Australian government endorsed position. So apologies to the ambassador and others, but I think that the power of the market and the innovation of firms is something that always absolutely staggers me. And there's not a lot of problems where you can't kind of give them a good framework and some assistance and point them at it, and through kind of trial and repetition and fast fail and error and collaborative partnerships and innovation, they won't come up with a solution. And so when I look at international initiatives, what I really look for in terms of merit is not something that's necessarily going to seek to create an enormous amount of architecture and bureaucracy and machinery and dialogues for the sake of dialogues and things like that. I look for frameworks that will create an environment that fosters collaboration and partnerships and practical action and tangible projects and incremental gains and rapid failure and rapid learning. I really like some of the way the Quad's been kind of focusing on practical things like around COVID and rollout of vaccines. I really like some of the bilateral work that we've looked at with the US, with India, with the UK, with Japan and Korea that sort of says, let's not talk about this thing for the sake of talking about it. Let's have a very specific outcome in mind. And let's think about what are the things we need to tackle. And then how do we bring research institutions together with firms, together with governments, across both sides of the ocean to actually put the best minds onto a problem and showcase solutions and then scale them up rapidly. That's where I think the benefit of some of these, that's where these initiatives can have the best benefit, when they're viewed as an enabling thing rather than something that focuses on creating additional rules for the sake of it. And I think, to go to your earlier question about lessons we can learn from our current kind of energy situations, I think the rollout of like microgrids and things like that in remote communities is a really interesting example of where renewables have been around for a long time, but suddenly we've decided that they can not just be attached to a building and part of a stationary thing as part of a big grid setup. They can be deployed in small communities in an innovative way as a hybrid system with batteries or with gas or with pumped hydro or with other things like that. And that's come about through, in Australia at least, targeted strategic investment from our Renewables Energy Agency, working with firms to do sort of seed investment in brilliant projects that half of them fail, but the other half really kick off, and then they become eligible for a pathway to commercialization. But it's working with the private sector, working with countries in the Pacific Islands to roll them out. Those are the sort of things that excite me about international initiatives. Thank you.
Thank you. That's great. We're now reaching the end of the allotted time. I notice on the program that I'm down to deliver some closing remarks. I'm not going to attempt to summarize what we've talked about today, but I would like to just, come back to one element that Dr. DeWitt mentioned, and that's the importance of an engaged public debate on these issues. And I think that echoes something that I think I heard from Dr. Wild as well. The lack of recognition about the importance of some of these issues as we move through energy transitions. And certainly from our perspective, as we think through some of the things that Nicole Thomas mentioned early on, and the executive director referred to in his opening statement about the importance of this issue in the run-up to our own ministerial meeting, we're hoping to get a very engaged debate among ministers in the first quarter of next year. And the sorts of insights that we've got from you all today have been incredibly valuable to us as we think through what are the priority areas that we need to be looking at, and also where, when we sit down with Taiyun and plan through some of the next analytical steps that we'll take from the IEA. So where should we be really focusing our attention in order to bring new insights, new data that will be useful to you all. So I'd like to conclude there with very sincere thanks to our excellent panel for their thoughts and for what I thought was a very wide-ranging and good discussion. But particularly also to my colleague Taiyun Kim, who's led the work at IEA and will continue to be an important focal point for our activities on this going forward. And with that, many thanks again. Many thanks to all those who've listened in, and we hope to see you again at IEA discussions on this issue. Thanks a lot.